Okay, so in the last video I asked you to do questions on page 374, numbers 1 to 4. So number 1 says, use the ray diagrams. Solve the problem example using the ray diagram. So if you look at the problem, the example problem, it says it's a 2 centimeter high object, 30 centimeters from the mirror, so we have our HO and our DO. And it says the mirror has a radius of curvature of 20 centimeters, which means our F is 10 centimeters. Okay? And so if you look, then it means our object is outside C. So our object is out here. Okay? And it wants you to find the image using ray diagrams. So, from the top, a ray going in parallel to the principal axis would come out through F, and a ray going in through F will come out parallel to the principal axis. Now, the textbook is really thinking you're going to draw this to scale, but I will never think that, okay? So you don't have to draw these to scale. From the bottom, a ray going in parallel to the principal axis should come out through F, or almost. And let's do a ray going in through C. A ray going in through C should come back along C. Okay, and so then our image, I got new pins, but they're really not that much darker. Our head should be where the green are crossing. The feet should be where the purple are crossing. And our image is going to look like that. It should be smaller, and it's between C and F, which is where it should be. Okay, number 2. Number 2 says, using a ray diagram, we have an object that's 3 millimeters, a DO, it's 10 centimeters away from the mirror, and the F is 6. So here's my F, and here's my C, and my object is in between, right? Between 6 and 12. So again, with the ray diagram, from the top, going in parallel to the principal axis, coming out through F, going in through F, having a hard time drawing parallel, coming out parallel to the principal axis. And my C is really too far away. My C should be here because it's 6 and 12, so this really should be C. Doing the bottom, in parallel to the principal axis, out through F, in through F, out parallel to the principal axis. And so my image, that one's not right. My image should be out here. Okay? And if it was to scale, it would be better. But I'll never ask you to do it to scale. But it does ask you to then find it mathematically. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. So 1 over DI is equal to 1 over 6 minus 1 over 10. Common denominator will be 30. So 5 over 30 centimeters minus 3 over 30 centimeters should be about 2 over 30 centimeters, or 1 over 15. So DI is equal to 15 centimeters. That's part B. Part C says find the height. So yesterday I had said magnification was equal to HI over HO. And when we put the DI and DO in, we usually put a negative on the DI so that if it's upside down, the HI will work out to be negative. So the equation here is really easy to remember. It's the 7 dwarfs. Hi-ho, di-do, it's off to work we go. So we're looking for HI. Bring the HO up. So HO, put the negative in front, DI over DO. So negative 3 millimeters times 15 centimeters divide by 10 centimeters. Now you might be saying, wait, they're not the same units, but look, the centimeters are going to cancel out, so it'll be okay. So it'll be negative, this is 2/3, so 2, right? 40, no, I didn't do that very well. 45 divided by 10, 4.5? 4.5 millimeters. 1.5, yeah, 4.5. And where the negative means, oh man, I screwed that one up. Where the negative means inverted, because the head is really down here. Man, ignore that. It is definitely inverted. Sorry about that. Good thing we did the math. Inverted. All right, number 3. This is where I need you with me to tell me I screwed it up. I was even using different colors and I still screwed it up. An object that is 30 centimeters from a concave lens, so DO is 30 centimeters. And the lens has a radius of curvature of 20 centimeters, which means F is 10 centimeters. Locate the object. It wants, the image of an object. So DI is 30, and it wants you to find DO. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DO is equal to 1 over F minus 1 over DI. So 1 over DO is equal to 1 over 10 minus 1 over 30. Common denominator, 30. So 1 over DO is equal to 3 over 30 minus 1 over 30, which is about 2 over 30, or 1 over 15. So DO is equal to 15 centimeters. Number 4. An old magic trick uses a concave mirror to project an image the same size as the object and the same distance from the mirror. If the object is 25 centimeters from the mirror, what should the radius of curvature be? So it's saying that the image is the same distance from the object, and it's saying the object is 25 centimeters from the mirror, so it means DO is equal to 25 centimeters, and DI is equal to 25 centimeters, and we want F. Really, we want R. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over F is equal to 1 over 25 centimeters plus 1 over 25 centimeters, which should be about 2 over 25 centimeters. Which means F is equal to 25 centimeters over 2, or 12.5 centimeters. But R is equal to 2F. So R is equal to 25 centimeters, which should make sense. The object and the image are at the same spot and are the same distance apart, or same size if they're at C. All right, then I asked you to do number 5 on page 376. Number 5 says an object that is 4 centimeters in front, so that's your DO, in front of a concave mirror having a 12 centimeter radius, so R is 12 centimeters, which means F is 4 centimeters. Locate the image. So 1 over F is equal to 1 over DO plus 1 over DI. So 1 over DI is equal to 1 over F minus 1 over DO. 1 over DI is equal to 1 over 4. I divided 12 well, didn't I? 1 over 6 minus 1 over 4. Common denominator is 12. So this is 2 over 12 minus 3 over 12, which is negative 1 over 12, which means DI is negative 12 centimeters, where the negative, if you remember from the last set of videos, means virtual. What that means is if we were to sketch it, here's F, here's C, here's the object, but the image ends up in behind, right? It's going to hit, reflect off, go through C, and you're going to have to follow them back, okay? Number 6 says a concave mirror has a focal length of 9 centimeters, so F equals 9 centimeters. A 15 millimeter high object, so HO is 15 millimeters.